So yeah, this is our intern presentation as the people who are not graduating this semester. So when we started talking with Ricky and Jeremy about our project, Olivia and I both expressed interest in looking at compound flooding, sea level rise, extreme precipitation in coastal communities, particularly interested in kind of like the Gulf Coast Southeast region. And around the same time, the NOAA Climate Program Office put out a request for proposals to for projects kind of looking into some of these same questions that we were interested in. And we ended up getting together with GLISA to write a proposal to look at compound flooding in communities in the Great Lakes, and partnered with the University of Georgia to look at communities there. And these are two distinct regions that have a lot of similarities in the fact that communities are increasingly vulnerable to compound flooding events, which happen when you have sea level rise, extreme precipitation, multiple flood drivers, with a classic example being Hurricane Harvey, where you had extreme precipitation, which caused a lot of inland flooding that couldn't drain out to the sea because of storm surge, sea level, and high tides. So there's limited capacity in a lot of these communities to adapt to these impacts. And the overarching goal was to bring GLISA's scenario planning approach along with a variety of other things to inform infrastructure and adaptation decisions in these areas.
Yeah, so like a little bit of outline that Michael covered a little bit. We worked with GLISA and the University of Georgia, and so there was 3 people specifically from UGA that we worked with that submitted this proposal. And we submitted it at the end of March, so we're waiting to hear back on funding about that. But if funded, the plan is to implement scenario planning across a community in the Great Lakes and a community in Georgia. So the Great Lakes, we're looking at doing Detroit. And if Detroit doesn't work out, Cleveland or Gary, Indiana. And then the Department of Defense installation on the coast of Georgia in McIntosh County. So like having specific communities that we are going to be involving with in this project, there's going to be 3 workshops. And total project's going to span 4 years, so we won't be around for that whole time. But if it gets funded, we might work on it in the fall.
Yeah, and so we had a couple different roles in preparing the project proposal. We co-wrote the background on compound flooding and implications for the Great Lakes and Southeast communities. Olivia worked on, I'll let you talk about it.
Yeah, I worked looking at specific data sets that GLISA can use in the actual project work. So there's a list of them right there, different data types, climate, lake levels, sea levels, flooding, inundation, and socioeconomic things. A lot of the data sources GLISA had used previously in some of their proposals, so they have experience with what they mean and what they do. And I'll talk a little bit more about that in my independent project in a bit.
Yeah, and I focused, other than the background, focused particularly on community vulnerabilities. I worked kind of modeled after a table that GLISA proposal I previously used to look at different potential communities in the Great Lakes and the Southeast and their potential impact factors, like, households without a car, houses that are rentals, households that have poverty, and how that overlapped with flood risk, presence in a floodplain, and then used Department of Transportation data to look at historically disadvantaged and persistent poverty census tracts in those same regions, and to kind of see how those spatial scales interlapped. And did the same in, I wouldn't put the table here, but the same for a couple of different communities in coastal Georgia. And moving forward, kind of in line and to bolster this, but also potentially as a separate project if this doesn't get funded. I'm focusing in on the aspect of it that has to do with appropriate regions of scale for climate planning, and I'll talk a little bit about that later.
Yeah, and I'm looking at transitional science and data, and then event-based scenario planning, which is similar to what GLISA does, but a little bit different.
Cool. So to focus on my aspect a little bit and what I'm going to be working on moving forward, the spatial scales at which adaptation planning happens can be really impactful and can view how different communities, actors, governments, organizations see trade-offs and co-benefits in planning, as well as how they prioritize and view risk. And that results in very specific infrastructure decisions that have very specific consequences. And one of the classic examples is that people who act actors, individuals, organizations, communities acting in isolation can make short-term decisions that have long-term consequences for either themselves or neighboring communities. I know Ricky gave the example in his talk how they put up a seawall and that can have impacts in coastal erosion increases in the areas next to that. And that's frequent in the Great Lakes too, in the Great Lakes region, something that we're looking at. And in the same way, top-down approaches to planning can often overlook community needs and priorities, nuances, and that can lead to either inefficiencies or negative consequences of maladaptation. I think I went. Okay, cool. So we decided to focus in and write a white paper talking about the impacts of regions of scale in trade-offs and co-benefits in decision-making. We started with some really big questions. How does scale impact views of trade-offs and co-benefits? And just to give some background context examples, if you're, for example, a city and you're talking about adaptation strategy being zoning laws, right? You might say that, well, if we increase zoning requirements or building codes to require energy efficient buildings and more durable materials, you get a co-benefit of mitigation and adaptation. But if you're looking on a regional level, that could increase property values, cause displacement, and cause vulnerable communities to move out. And something called, it's climate adaptation gentrification, and that could be a regional trade-off as opposed to a local co-benefit. And so how do we go about identifying what the appropriate region of scale to plan on is, if there's all these different factors and overlapping layers of jurisdiction and governance, et cetera. And so after talking with Ricky and Jeremy, started to try and focus down a little bit on some kind of smaller questions, which I'm still in the process of doing, I would say. But specifically looking at, if we're gonna maybe evaluating some things that have happened in the past or are going on currently with regards to scale enabling or acting as a barrier for climate action in cities and in rural areas. I think I've been focusing more on the municipal aspect just because there's more resources available for that to analyze. I'll talk a little bit about that later. And then what kind of information we might need to assess whether or not something is an appropriate scale for adaptation, how we might go about thinking about that. So a lot like our country's approach to dealing with climate issues, my research has taken a bit of a patchwork approach. So I started at Ricky's suggestion by kind of just reading a bunch of climate action plans in the Great Lakes and in the Southeast and in a couple areas across the country. This is a really cool tool from Georgetown that basically shows climate action plans in different states and different cities and kind of compiles them, provides summaries. It's not all the way up to date. I think the more recent ones are around 2020. But anyways, I was trying to pay particular attention to how different plans viewed risk, what the priorities for action were. And a lot of these had to do with mitigation, not adaptation, but there were some more adaptation-y related planning, and what the scale they were planning on, how that might influence that, and generally just trying to get a feel for what decision-making and planning in the climate space looks like and what the outcomes are. And then did a bit of an informal literature review on just decision-making strategies, climate decisions, the physical scales of climate impacts and features, which was really helpful to do the background on compound flooding to kind of get a sense for how those things played out. And then looking at a bit of historical evidence for how, our systems, infrastructure systems, economic systems, bureaucratic systems evolve to manage these natural features and resources to see if there might be some synergies there that we could leverage. So a couple key takeaways. Well, this is actually a picture of Georgia watersheds and counties, and I think it illustrates a really strong point, which is that, while there may be a strong case for adaptation planning around physical features like watersheds, right? There are a lot of problems relating to jurisdictions. Rivers become borders, and therefore watersheds are shared and managed by multiple different entities that surround them. Jurisdictions often don't overlap with the actual features that they lie in or that these climate impacts happen on. You can see here, these are smaller counties in Georgia, and then these are the watersheds. So if you can imagine trying to do watershed scale planning with, 30-something counties that are either fully or partially in different watersheds, these are places that may not have the infrastructure to plan on that scale. And so doing that would require the construction of a whole different set of decision-making infrastructure. And that speaks to a lack of coordinated planning generally, And even when you do have coordinated plans, for example, the Miami-Dade County region has a coordinated climate action plan. The Chicago, Illinois region has a coordinated regional climate action plan, but a lot of these governments don't have, or these regional governments don't have authorization to actually make any decisions. That lays with the authorities that rest between them, which creates tensions and problems. And so, you know, one of the ideas is that, as Ricky often says, that adaptation needs to become a part of just what we do, right? And needs to become integrated into the other ways that we plan and manage natural resources. And that's certainly a good strategy. A good example of this is climate smart capital improvement planning, which is something that was pioneered by the San Francisco PUC, where basically there's climate criteria for adaptation and mitigation into every capital improvement that goes through. So if you're gonna, you know, drill a well for an aquifer, or if you're gonna upgrade a water system, like there has to be some sort of climate consideration aspect to that. And plans are allowed to be amended early for adaptation purposes. So that's one thing, but at the same time, that can lead to other kind of jurisdictional problems if you're planning on a particular scale, but that has impacts around you. You know, it may be an easier thing to do, but it may not be the most effective way to go about it. And there's definitely a tension between kind of what's thought of as municipal metropolitan statistical area kind of decarbonization, which is again a strong case for that. You know, you have metropolitan statistical areas that are defined by their relationship to housing, transportation, economies. These are areas that normally have a city center, but kind of sprawl. You can think about, you know, the Detroit, Warren, you know, metro area, the LA metro area, you know, the San Francisco Bay Area metro area, right? And there's a strong case for decarbonization here. But because you're trying to decarbonize the systems that connect these areas, but if you try to incorporate adaptation into that, that comes up with a lot of interjurisdictional problems. Like water resources aren't managed by metropolitan statistical areas, they're managed by counties, they're managed by cities. You know, flood control infrastructure is managed by local individuals or a homeowners association. How do you incorporate that into a broader regional governance? And is that the most efficient way to go about it? So of course, the general tension is that there's a fundamentally unequal distribution of rewards, risks, and responsibilities across different scales of governance, especially when it comes to climate adaptation. So, you know, one of the interesting things I came across last month, the White House Council of Economic Advisors put out this presidential economic report, and they had a section on the economics of climate adaptation. And they were talking about how, because the federal government takes on a lot of climate risk in the form of disaster relief, backstopping home insurance from flooding, all of these different things, that creates counter incentives for individuals to buy homes that isn't priced into in those areas. Or if a city government wants to develop a subdivision in the mountains and increase their tax base, they're not necessarily responsible for fighting those fires. They're not necessarily responsible for insuring those homes. So fundamentally, the distribution of these risks is unequal. And I think that there's a lot of interesting stuff there around the ability of the federal government, states governments to kind of set incentives and to help determine the structure of these regions of climate action and climate adaptation and planning moving forward through their incentivization. So looking back on this project a little bit, and moving forward, next steps, I hopefully would like to identify a few case studies that might be illustrative and that might be helpful for the GLISA UGA project, either communities in those regions that have done some planning or similar analogous communities that have done different things. Maybe going into kind of like a more quantitative analysis of where jurisdictions are, how they overlap with physical features and risks, and how climate planning on those scales happens, and then using that to evaluate whether or not things have gotten done, whether scale has been a barrier to implementation of climate plans, that sort of thing. And then potentially interviewing practitioners, urban planners, people in the field to get a little bit better sense of a take on it. In terms of lessons learned from the grant writing and proposal process, definitely how teams and projects come together was a big thing, that and how messy it is at first, and it's brainstorming how quickly that these kinds of things can come together. It was really interesting. How to kind of find relevant and or find relevant information when you're given kind of like a broad directive. Like if it's like write a background section on compound flooding and how it impacts these different communities. That's a really broad mandate, right? Thinking about how you're framing the project, how the information that you're using might further the narrative. And then understanding these really kind of weird tools like the one used to understand flood risk and intersections with socioeconomic vulnerabilities from headwaters. When you go on that website, it doesn't tell you what those percentages mean. It doesn't tell you what the things you're putting in actually, how they'll relate to the number of people who end up in counts. Like understanding what the climate information is, and I'm sure Olivia will talk about this later, was something that I had to get accustomed to doing that. And then again, yeah, difficulty answering kind of broad open-ended questions. How does scale affect climate adaptation? Is like a really broad question, and trying to think about like my sub kind of what along the lines that I want to go and research into. So that's me.
Well, that was a great transition because now I'm about to talk about how a lot of like climate data that's out there isn't exactly easily accessible by a lot of communities that need it. So broader question that I was looking at for the second half of the semester after the GLISA project was done was what kind of data is available and what kind of data is usable to decision makers. So this is what's referred to as transitional science, which is effectively what GLISA is doing. Like looking at the data and then translating it into some sort of story or information that's more accessible to cities at like Detroit or communities on coastal Georgia. So a few examples of this kinds of data include resources from NOAA and FEMA and the US Army Corps of Engineers, so list right there. A bunch of those are currently used in the GLISA UGA proposal. So sea level rise trends, sea level rise technical report that we all know about. And then like some coastal flood frequency data and types of neighborhoods and stuff that are affected by floods frequently. So essentially what this boiled down to was a lot of reading on, you know, why there's a lot of maladaptation, like seawalls, like Michael mentioned earlier, is because a lot of people don't understand what the climate data means and what to do with it, and how to predict that kind of future. So spent a lot of time this semester sort of looking at data sources, data plans, what they mean, and you know how you can infer things from each of those. So I have like a sort of another project that's an offshoot of GLISA's, the GLISA UGA proposal that I'm going to be working on a lot more next semester. So essentially what it is taking the scenario planning approach that GLISA has and making it into an event-based storyline. So looking at what sea level rise means for a community like coastal Georgia, and then if a hurricane comes along with an increased sea level, how that's going to impact the community. So essentially it takes plausible high impact future events instead of just probable sea level rise and uses that to inform communities of disaster risk. So spent a lot of time in the last couple of weeks also looking at disaster risk scenarios and how communities are effectively pretty much unprepared for events like that, given the changes that we're going to see in the sea level. So the focus of the strategy is on uncertainty of the events. So we know that they're going to happen, but we don't really know when or how bad they're going to be. So if a hurricane like Hurricane Harvey or Hurricane Hugo, like in 1989, like if that were to happen now, what's going to happen? So that's the goal. Do you want to go to the next slide? So how that really is going to work is I'm looking at two potential communities right now and potential events in each of those communities. So coastal Georgia, like the UGA GLISA project, so that would tie directly into that one, but be approached a little bit from a different point of view with an event I think there's Tropical Storm Alberto, which is pretty bad. It had 100-year flood levels in like 1990 something. So that's a potential one. And I was also looking at considering Charleston, South Carolina. So that's where Hurricane Hugo hit. And that was pretty bad. There was like extremely significant flooding and a lot of loss of lives at that point. So once I've chosen a community event between those two, I'm going to look at the community's vulnerability to flooding using a lot of the data sources that I've already spent a lot of time looking at and trying to understand. And then using tiered scenarios of sea level rise, so low, medium, and high levels of sea level and how that's going to change given an event like Hurricane Hugo. And that's going to use NOAA sea level rise scenarios and historical hurricane tracks data. And then essentially this boils down to wanting to be able to present this kind of data in a palatable way to communities that don't understand climate data. So going to take all of that information and put it into a storyline / narrative that's easier to understand for the community. So summary and conclusions of my little mini project that I haven't really started yet, but I will get to in the fall, is oftentimes that data is not really translated well to policy and decision makers. Scenario planning and storylining is extremely helpful and not used all that much right now. Right now, storylining actually is used a lot more in Europe than in the US. And there's like a lot of studies in like Germany and Italy using that kind of thing. So it'd be good to be able to adapt it to the US. Community involvement is key. So if you make a plan and people can't do it, it's not really gonna work. And like Michael said, like lessons on how funding calls and writing proposals for grants and stuff works is definitely extremely valuable to be able to see like GLISA as a powerhouse of writing and knowledge. So deliverables, a white paper on the results of the storylining project that I'm working on, and then potentially helping Ricky out with a scenario planning guide that he's already put some work into. And that is the end. And I have a few additional slides.
But yeah, did anyone have any questions?
Yeah, let's open up to questions from the audience and also Ricky.
Yeah, I don't know how to check that.
I have a question on like Olivia's side of the project. So as far as looking at like past extreme hurricanes or like extreme events, do you choose those because you imagine that would be like honestly like the average hurricane in the future when like storms and such are more extreme due to climate change? Or is there a plausibility that like that could even be like kind of like middle ground level hurricane like later on when storms are more extreme?
It's potentially could be middle level. I mean, we don't really know. I haven't like spent too much time on it yet, but assuming that like a horrible hurricane that happened now is going to be extremely worse, you know, with sea level rise and things like that. So yeah, I don't know if that answered your question.
I think part of the challenge is figuring out what the scenarios are, right? Yeah. Like, so you could take a hurricane that's pretty historical and say, okay, but if we had a foot of sea level rise, what would it do? And this is a pretty normal type event that we expect. You could also say, well, what happens if we had more sea level and even stronger hurricanes?
Yeah, that's
so
right.
Yeah. So I think you did a good job explaining that. It's just a question of finding the scenarios is what you have to kind of really work hard at.
Yeah, that's sort of like the point of like the tiered sea level. So like the low, medium, high would be like, you know, with like an average hurricane, and the low level is going to be different than an average hurricane in the high level. So.
Erin, you had a question?
Yeah, I have another question for you. Do you know why many places in the US don't use a storylining approach?
I don't think it's just, I don't know. My interpretation is it's not broadly advertised.
Okay.
But I'm not really sure.
Makes sense.
I think some places do and call it different things.
Okay.
So storyline, scenario planning, there's a lot of similar things out there under slightly different names.
And sorry, that's different from what, because yours is more like attribution, right?
I'm doing it, it's like what I'm doing is more of we're taking an event that has already happened and seeing how much climate change has affected it, as opposed to taking an event in the future and like taking some future scenario and seeing what effects climate change might have on that. Gotcha. Yeah, it's a little different.
Josh.
Great work. Part on that proposal for sure. Michael, you're talking about the scale of all these things, and I'm wondering if you have thoughts on how limited jurisdictions might impact the ability of collaboration, of being able to kind of work on these things. I think about if you're a local town or city, you know, you're really pretty limited unless you kind of get the next town over to get on your train, what you can do there. And maybe you can get the state level involved, but then that takes you up a big notch. And even a consulting group is pretty limited to what state or not state, community they're working with. So do you have any thoughts on that yet?
Yeah, I think that that's exactly one of the problems that this is kind of trying to think about. And the idea that if you have a community or a county with limited actual institutional capacity, like the ability to hire people to work on these things and collaborate and like build that cohesion with neighboring areas. Like, I think that be a really big problem. And I think that it could also potentially lead to kind of, maladaptation. You see this in like California with the floods right now in farming communities, where some people are being accused of going up and breaking levees in the county north of theirs so that their community won't flood. And so like the problem is that you can have even less than maladaptation, you can have no adaptation or intentional sabotage, right? When you have kind of like these silos. And so I think that finding a way, and maybe like, you know, this is part of the thing about thinking about appropriate regional scales, is like if there's a compelling evidence or narrative, like this is the best strategy to deal with this sort of scenario, like that might encourage people to collaborate more.
Cool. It's a hard question for sure.
Yeah, I think Ricky might be able to talk a little bit about that.
All right, I will give Ricky an opportunity to pose some deep provoking questions, but first I just wanted to read Heather's chat comment, which I think is a pretty good one, which is that Heather pointed out that you see pretty similar concepts in other fields, especially health. And so I think that the thing is that scenario planning, storylining isn't necessarily a new thing, but it's constantly reinvented. And I think climate has been one of the slowest to adopt it in some ways.
Yeah, I was gonna go off that. I read actually a lot of articles that were like how health impacts are gonna change due to climate change that were sort of scenario planning things, and a lot of like ecology sort of things, but not actually climate science.
Lots of ecosystems, right?
Yeah.
Like it's heavy in ecosystems. I was gonna say, Michael, that you're taking a big problem and then breaking it down into smaller problems. Your smaller problems seem pretty big to me.
I know. So one of the things that like I didn't put in the, I think I had it in speaker notes, but I couldn't see speaker notes. Is like one of the things moving forward is going to be like working with you and, you know, trying to figure out like specifically what smaller questions we're going to ask, which is why I think like a case study, like I started narrowing it down to like, okay, specifically related to compound flooding, specifically related to flooding. Let's not think about all these other potential climate impacts. And then limiting it to some case studies might be really helpful. And yeah, so ways to kind of like narrow and focus so that it's not like, yeah.
I was gonna say, just building on Josh's comment, like to me, a very big and challenging problem is going to be cooperation versus competition.
Yeah.
That two communities might end up in competition and maladapting because they can't cooperate.
Yeah.
And you think we see this all the time. Like, I mean, I think Ricky's the champion of maladaptation with his seawall that, not to pick on you, Ricky. I think that we had another question and then maybe we'll open up to Ricky as well.
Yeah, on Michael's end of it, I don't know if you have thought about this yet, but do you foresee that like your kind of like point or argument eventually, like in your paper, like you're up and down the road, would be more on the level of like, this is the scale at which climate adaptation is the most successful or is the most effective and why? Or do you foresee it being more like, these are a lot of the obstacles and problems with climate adaptation on these various scales, and here are like strategies for overcoming those obstacles?
Yeah, I think that the two are really related. I think that like the problem is that the appropriate region of scale for adaptation is going to be very different in different places and for different types of events. And so I think that where I want to start, before I even go into like making an argument about this is what should be in a certain place, I want to start with kind of what frameworks could you use to evaluate what might be an appropriate region of scale, like, and that starts with like what has worked in the past and what hasn't worked in the past. When it acted as a barrier? When has it acted as something that enables action? And then maybe eventually moving forward into like a position, but I don't think I'm nearly far enough along in my thinking or research to like take a position and say like, you need to have it be, you know, watershed scale in this because for these, you know what I mean? Like, I don't think but maybe it could turn into that if I have some type of stroke of genius regarding a certain place-based solution, but we'll see.
We have confidence in you. Let me pull up Caleb's and Ricky. I'm sure you have something to add.
All I was really going to add was one comment while I'm remembering it, for you, Michael. If you look at the RISA that's in New York City,
Mhm.
and you might want to interview Cynthia Rosenzweig or Bradley Horton. They had to get together, as I recall, more than 800 water districts. So you might just think of an interview to them of how they did that engagement and thought about it.
Yeah, that's a great idea.
And then the only other thing I can think of is you two did a great job. So that's it.
Yeah. You guys both did a great job, and I've been asked to take pictures, so like when I'm on my phone up, it's not that I'm just like it's not that my eyesight is that bad that I'm holding out there trying to read my text message.
That's a dangerous.
Oh yeah, shout out to Olivia for formatting all the references in the GLISA proposal. Ricky and Jen just write and then they put cite. And they're like, can you go through and find the citation for this?